So today we will solve some problem on silvering of lens. So how silvering of one side of lens converts it into mirror. So eventually we have to find the focal length of the equivalent mirror system. The method of solving such question is called method of power. So when we have combination of lenses, then power gets added, and that we have proved using the combination of lens derivation. For lens, the power of lens we write as 1 by FL, and by default it will be in air. Now, for a medium, if it is said that find the power of a lens in a medium, so for power of lens in a medium, the formula will change to mu medium by FL. And from lens maker formula, we know that for lens maker formula, we know that what we know 1 by FL equals to mu lens upon mu medium into 1 by R1 minus 1 by R2, and therefore mu medium by FL will become mu1 minus mu medium. So you can say in general, this is for air. So for medium, the power difference is mu real minus mu medium. And just as a recap, for um, mirror, the power we write as, and what else we need to remember that for converging system, it doesn't matter whether it is a mirror or lens. For converging system, the power must be positive. For diverging system, so just in case, let's say if you forgot about the formula, let's say if you have a confusion or a dilemma in the sign convention, try to make sure that okay, if it is converging, just the answer should be positive, and if it is diverging, the answer must be negative. If you remember this part also, probably you can eliminate the basic error in the calculation. Okay. So let's say we have a so now the bottom surface of this concavo convex lens is polished or silvered, and object is at a distance d from the P point, and it's a thin lens, so this thickness must be ignored. The radius of curvature of this is 20 centimeter, and this is 60 centimeter. So for what value of D, image will coincide with object? Tell me. For what values of D, image will coincide with object? Refractive index is 1.5. The mu is so first step is find the equivalent focal length of the system. So by the power rule, what we can say? Power of the system is twice the power of lens plus 1/7 power of mirror. And we have discussed about the power. It is about the number of diffraction that the light, not number of the number of times the light passes through the lens, and number of times the light suffers the reflection. So together we call the total power of the system. So E equivalent we can attach twice of, and the power of lens will be how much? So we can do it separately first. So power of lens, we know the formula is mu lens minus 1. Because we have to find this in air only, which is 1 by f. Lens make a formula. So this becomes 1.5 minus 1, which is 0.5. And if you take the light ray from top, the R1 is minus 60, R2 is minus 20. And you can clearly see that the answer is positive, right? Because it is converging system, so we were expecting the same. So this turns out to be how much? 1 by 60. So, okay, we can keep it to 1 by 60 as a value. And for mirror, we know the answer is R by 2. Uh, sorry, 1 by F, and F is R by 2. So now it becomes 2 by R. So now if you substitute the value, and the R will be, so we have, sorry, minus here. And R itself is, here you can see, is minus 20. So you can see again the answer is positive because both are converging system. So we know that concave mirror is converging and convex lens is converging. And therefore the P equivalent we can add as twice of 1 by 60 plus 1 by 10. So if I take one more step, 1 by 30 plus 1 by 10. So how much is this? 3 plus 1, 4 by 30. And now we can write it eventually as minus 1 by F equivalent. So the F equivalent comes out to minus 7.5. So here minus is representing what? That it is concave mirror. So the equivalent system will act as concave mirror. And because the equivalent system will act as concave mirror, therefore, to form the image back to the object, the rule is what? Can directly answer. It is at center of curvature, isn't it? So when the object is at center of curvature, then only the image is formed at the same place,
2f.
which is 2f. So the value of d we can attach twice of mod of f, because we just be one value, right? So the answer is 15 centimeter. D should be the value. If you don't want to solve like this, let's say if it is not the center of curvature, which is famous, use the mirror formula. Then once you get the P equivalent, the rule is use mirror formula, and you can substitute minus D, and V is minus D, and F we got minus 15 by 2. So it is similar to the same, like 2 by D is 2 by 15, and so D is 15. You can solve from the basic and get the answer. The only thing is you have to be careful with the sign. Generally, the doubt happens with the sign. Many students they fail to get the sign part.
Sir, I didn't understood the negatives and f equivalent.
Pardon?
So I didn't understood the negatives and the f equivalent.
D is the value. D is not negative. When you substitute D, then it is negative. In the mirror formula, D is negative. No?
Um,
Every distance we measure from P, right?
yes.
Any doubt in this?
No, no.
Okay. So imagine this situation. So we have a so now we have a let's say this is equiconvex lens. And let's say radius is 60 centimeter each. Or maybe I can keep it smaller. And the bottom is the plane itself is silver. The mu here is 1.5. And now the space which is left is filled with water. And the refractive index of water is 4/3. And now ignore the thickness. I mean, of course, I have done too big for the clarity of diagram. Otherwise, it is not required. And now we have the object. And I want to know the D value such that the object and image distance one side.
So this is the divergence.
So you have to think about whether the system is overall diverging or converging or whatever. So find D such that the image coincides with object. Done.
Also,
So here we have the P equals to, if I call this first lens as one, but this is also a lens. So the P equal to connected is twice of P of the first lens. And so for we have to write the second lens also, and then mirror one, because we have to think about the refraction. The light will pass through the both lens twice and will reflect only once from the mirror. And because it's a plane mirror, so the PM will be 0. So the P equivalent we can attach. Let's find the P1L. So P1L is pretty much obvious. Mu minus 1, which is 0.5. And it is 2 by 20. No problem. So
0.5 by 4 into 2 by 3.
if you're not getting this, I'll just write everything. So it's mu minus 1 into 1 by r, which is plus r minus 20. This will give you how much? 1 by 20. So P2L will be how much? So mu minus 1, 1 by minus 20. It's a plano concave lens. So infinity term we can attach. And so what we are getting here?
Oh, sir, in the second part, try 1 upon minus 20.
Yeah, tell
1
me.
by 20 minus 1 by.
So 1 by 20 we got, and P2L we are getting 1 by 60 minus 1 by 60, right?
So that I understood the 1 by minus 20.
What you're saying, I don't know. So it is 2 into 1 by 20 minus 2 into 1 by 60. So 1 by 10 minus 1 by 30. And if I take 30 as LCM. So the P equivalent again turns out to be, now this time it is 15. I mean 1 by 15. So it is minus 1 by F equivalent. So here F equivalent turns out to be minus 15. And so 1 by V plus 1 by U. 4. So 1 by V want we want answer is minus D, and 1 by U is minus D. And F is minus 50. So D equals to 30 centimeters answer. And in fact, if they say okay, some other location, this is the best way to go ahead. Okay. So you understood the process?
Yes.
So rest I have shared the subjective question of optics. Now you can solve every question that you have seen so far. And now we can move to the next topic, which is called the defects of vision.
So this is the last topic.
Second last, we have optical instrument after this. The defects of vision is generally 4 types we study. There are many, of course, there are many. So we study myopia, or called short sightedness. Second is called hypermetropia. Some author writes Hi, Piero Pierre. And then we have astigmatism. And then we have color blindness. So our syllabus is about the first two in terms of mathematical derivation. The rest is of no use. I mean, you just need to read. You can read S. Verma as a theory. So astigmatism is about the plane of wave entering the eye. So it's like the shape of the cornea is disturbed. Okay. So anyway, so before we start studying the defects of vision, there are two things and two very crucial things that we need to understand. So there are two things which is called the near point. Far point. So for healthy human being, the average near point is a assumption actually. So the near point we write as NP. We take as 25 centimeter. And it is assumed that this is the separation at which if you keep any object, then the image will be sharp and contrast. So you can see the brightest image and the biggest image without any blurriness if it is kept at 25. If it is at less than 25, then the image will be bigger, but it will be blurred. Now, this is not true in general because a small kid can see even at 6 centimeter distance with clarity. And as we grow old, in old age, it goes up to few meters also. So this is like world average taken, I think. I mean, how they have come to know about this number is still this is not clear, but the near point for every human being without any defect of vision, we have to take as 25 centimeter. Okay. So if something is closer to 25, then you cannot see it. Okay. So how to see object which is very close? So and what is the problem with the very close objects? If I draw
Sir, but I didn't understand the new point.
near point, near, not near. It is near point.
Yeah, but I didn't understand it.
Just imagine this is a human eye. So light will enter from the iris or pupil. What is that? Pupil. So for human eye, this part is called cornea. I hope you know.
Yeah,
And this small hole aperture is called. This is called iris. So iris can contract or expand. So iris like a automatic window And the role of the iris is to decide the amount of light which can enter the eye at once. So it makes sure that okay, too much light is not entering, just sufficient to form the image. So when you go to a brighter area, the iris will be almost closed because the light is too much. So it will be very close, and suddenly if you enter some dark room, then the light is not sufficient to make any visible. So the iris will take some time to open itself. It is like self-adjustable window, and the role is to control the light flow, how much light is entering or not. Amount of light decides the intensity, or so to say, brightness of the image. Okay. So now cornea is the it's like the frame on which this iris resides. Okay. And by moving the cornea, you're able to what you say, cornea or sclera? Sclera is called this one. Let me see the human eye.
Sir, then which is pupil?
Just
The pupil is ahead of cornea, which like allows the limited amount of insight.
yeah, the cornea is the outer surface, which is correct, and iris is the that entire part, and inside the iris we have pupil. So you must have seen a small darker region, right? There are three layers actually. So iris is the bigger layer. So what I have shown is actually, let me rectify this. Yeah, what I have shown is the pupil actually. And this part, which is slightly darker part, this is called iris. Okay. And the outer layer is the cornea, and the inner layer is called the sclera. And we have some human lens inside. And this lens is attached to the ciliary muscles. Ciliary muscles. And this is the lens. So the liquid on this region, there's a liquid in this region. This is called the aqueous humor. And the liquid which fills the entire part behind. Anyway. This is called VH. Vitreous. Yeah. I'm not sure about the spelling. That's why I'm writing in a way that you can't read. And then we have retina, which is the back mountain, and we have something here is called the most sensitive part, fovea, and we have this is like a connection, the neural connection to the or what to say is called the optic nerve. And these, whenever the light is incident here, this is the retina part. So through the optic nerve, the information is carried forward, and the information is eventually taken to the a part of the brain which decode this as a image of something. Okay.
So the medium is vitreous humor.
Yeah, medium is vitreous. So we have lens, we have aqueous humor, we have vitreous humor. Okay. And of course, I mean, don't take this diagram too seriously. Okay. This is just from my side. Okay. So the darker part is the entire darker part is called iris, and the pupil is the basically the actual opening through which light will enter. So by changing the size of the pupil, you decide how much light will enter, and that light eventually forms the image. And so that in the defects of vision, in the vision main property, first thing is like if we have any object, then light will travel from the object and will sustain some angle on the retina like this thing. So of course you don't see object the way it is kept. What you see is the curve part like this. This is your image, and of course this is too big to be shown here. It's a very small object. Now theta is something that we call the image size. So for brain, the size actually means angular size, not the physical dimension. And that is why no matter how big the object is, our perception of size is how far the object is. So when the same object is very far away, we see as a small object. And when the same object comes closer, it becomes large object, because everything is dictated by the theta. So we are not able to see the actual size. We are only able to perceive the angular dimension of the object. So no matter which object you talk about, it is the angular dimension which decides everything. It is clear? Now, one thing is sure that for a given height, the angular dimension will change as you come closer, isn't it? So as you come closer, what will happen? The angular dimension will grow in value. Do you realize this?
Yes.
Yes or no? So when you see the biggest size, of course, when it is almost close to the eye, right? Almost touching the eye. But the problem is if you are very close to the eye, and of course it will be bigger, but it will become blur actually, isn't it? So we
Yeah.
want a separation between the eye and the object so that it is biggest possible without being blur. So I want a sharp and contrast image of an object which is maximum, or you can say mostly, I mean, maximum magnified, you can say, or maximum in size without being blur. Are you getting it? So the closest point at which you can see the image clearly, or you can say object clearly. What does it mean? The nearest point, the NP. Are you getting the idea? What is NP?
Yes.
So NP means it is the nearest point at which if the object is kept, then you can see its image clearly, or you can see the object, you can say clearly and magnified, like of biggest angular dimension. So the 25 centimeter is that distance at which we see things clearly and the biggest size. I mean, here size means angular size. Is this clear now? Hello, hello.
Yes, sir.
So what is NP? The nearest point at which the object can be seen clearly, right?
Yes. Yes, sir.
Yes, sir.
And therefore, what happens like for a small child, this is not 25, of course. For child, it starts at 7 centimeter. But as you grow old, your nearest point becomes up to 200 centimeter, which is like 2 meter. What does it mean? So if your grandfather is without glasses, and if you're trying to come closer to him, he won't be able to recognize you. But if you are far away, he can see you. Okay, my grandson is coming. But if you come very close, then he won't be able to see you clearly because the image becomes blur without glasses. Okay, because your near point is not so less. The near point has gone far away from you. That is called a shifting of near point. Okay, so in that case, you use the which mirror? Convex.
Convex.
Convex, yeah.
Yeah.
Because you want to bend it more actually. You want to bend the light more, so you use convex because your eye is not able to bend the light sufficiently. Understood? So it is getting defocused. It is going beyond the retina in terms of focusing. Okay. The far point is infinite. Like we can see stars. That's why for a normal human being, the far point is infinite, and that's why we believe that we can see infinity. But the same thing, in a very young age, you can't see the distant object very clearly. The reason is the eye is so powerful, it will bend the light before the retina. So the light before it reaches the retina, it gets bent down, and therefore, while it reaching the retina, it is blurred now. So because of this blurriness, I mean the visibility is not clear. Although you can see a big objects without much difficulty, but when it comes to the alphabets on a blackboard in a school, you find it difficult to see the alphabets, right? But of course, you can see the blackboard. That's not a big deal. The issue is the smaller objects. So what is happening is the eye is actually powerful. It is bending the light a lot. So we put a concave lens in front of the eye so that the incoming light ray first diverges, and then when it converges, now it converges at the retina, and you can see it clearly. So that's why uh, in the young age this generally happens. Okay. So far point for a healthy is taken as infinity. The near point, as I said, it varies from age to age, but the maybe this may be the World Health Organization WHO standard. I don't know who has decided. Never found some text regarding the decision behind 25 centimeter. But now this is like a de facto. It is like the standard which you need to believe. And in fact, this 25 centimeter will be represented by a symbol D. And the D is called least distance of distinct vision. which means you can see it clearly, and it is magnified also. So first of all, the size of a object, okay, for a human eye is not the linear dimension, but the angular dimension. Okay. So it was also asked in the some JEE mains examination that what do you mean by magnification by the eye? So human eye do not see the HI by HO. No. Human eye only see theta by theta naught. Okay. So what is theta naught? If the object is at exactly D, then this angle is the biggest angle you can see with clarity, and therefore the theta naught is called the biggest angle or biggest size of the object, which is h by just like tan theta formula. And for paraxel, as theta is tan theta is theta, so we write like this. So this is called angular dimension of or angular size of object. Angular size of object kept at LDDV. What is LDDV? Least distance of distinct division. Understood? Least distance of distinct division. So at 25 centimeter, for eye without any defect, if object is kept, you can see with clarity. So to improve the to create the magnification, what we do is we don't bring the object closer, because if I bring more than less than D, it will become blurred. Rather, we create we take a lens, and the lens will form the image which will be far away from the D, in fact, with bigger angle. So we'll see in the microscope or the optical instrument chapter how it is done. But as of now, what you should remember is that in the defects of vision, the human eye will see the object at 25 centimeter with in a biggest size and in a clear manner, and that is why the 25 centimeter is the standard for the near point for average of human being, it is taken maybe. So we'll start with myopia. What is myopia?
Short sight.
It means you
Vision
can
defect.
see, yeah, you are good to see the nearby object, but not the farther object. So an eye can see the nearby objects clearly, but not the. So what does it mean? The far point which is supposed to be infinity has come down to a finite value, isn't it? So if I do the human eye again, Okay. So, we want this. So technically, when the objects are okay, what is the actual far point? Infinity. If the light ray is coming from infinity, it's very difficult to do here, but you can understand roughly. I'll do a simplified version of that. So if the light ray is coming from infinity, which is our actual far point, what will happen? Because the human eye lens is converging, so it will bend the light. So there are two possibilities. First is the bending is too much. Even the minimum in the most relaxed position, this is the bending that the light ray will suffer in the most relaxed position. So generally, when we see at a distant object, our eye lens is in the most relaxed position, and that is why the open space gives you good vibe. Okay. Then a very close enclosure. So many one will have the acrophobia, the fear of closed space. So when you go to beaches or mountain, you feel good because whatever right now you're looking at is so far from you that the brain is at ease in terms of processing such images. The eye lens is relaxed, and therefore we feel some sort of serenity or calmness in the nature. The reason may be other also, but this is also one of the reasons that the feel good factor comes from the relaxed mind, the relaxed brain, and also there is not a vibrant pattern of the nature. You see, if you're looking at the ocean, it is almost similar in nature. If you're looking at the mountain, it is almost similar, and therefore when the brain sees something as a pattern, it is able to fold the pattern and store in a small memory space, and therefore yeah, the entire process brings the brain at ease, so you feel calmness, you feel relaxation. Okay. So in the relaxed state, if you're looking at the farthest object, like any distant object, and if the light ray is coming and bending, after bending it is converging before retina, then you have the problem of which problem? Which problem you have? Myopia. Okay. You're not able to see the distant object. So the problem is I want this convergence to be taking place here. So that okay, what are the possible reason for this? Why this happens? So the one reason is extended eyeball size
Sir, for myopia.
for my.
Okay.
So you can see the retina is far away, na? So it is bigger than actual size, right? So
Yes.
the extended eyeball size. So basically, you can think, okay, this is genetic issue. Okay, the person born from a certain lineage will have a bigger eyeball by birth, and therefore this problem will be by birth only. The other reason is the refractive index of the aqueous humor, vitreous humor, and the eye lens. Now, refraction, when it comes to the refraction, the light suffers maximum refraction while entering the eye in the aqueous humor itself. The eye lens, the vitreous humor, the aqueous humor, their refractive index only differ in the second to third place of decimal. So if I say the lens is 1.5, hypothetically, Then the vitreous humor may be 1.48 and this may be 1.47. I mean, these all are very close. So it is said that the refraction occurs for the light almost when it enters. The other refraction is almost of no use. I mean, that is not sufficient. But when it comes to the image formation, this slight variation, very small variation, maybe the third or fourth place of decimal variation in the mu is sufficient to form the proper images. So the reality is the refraction is taking place while entering the eye itself. That is why every distance we take from the eye level only. So we take everything from here. We don't consider the actual lens as the optical center. Our optical center is this point itself. The point where the light ray is entering is the point of interest for optical center. So we always consider the optical center at the entrance itself. Okay. The reason is most of the reflection is taking place there. Inside the actual light, the reflection taking place is not much. It's very, very small because the aqueous humor, vitreous humor, and the human lens, I mean eye lens, all will have almost similar refractive index. In fact, let me search about it. So the index of reflection of cornea is about 1.376. Okay. Aqueous humor, humor, HO. Yeah. So aqueous humor is 1.336. The lens is 1.386 to 1.406, and the vitreous humor is 1.337. So this is the model I'll just share with you. Look, you can see it. Okay. So the N you can see 1.386 up to 1.406. And therefore, when you enter from A to the aqueous humor part, the maximum reflection will take place there only. Because from 1.336 to 1.386, you can see the decimal place is second onwards, we have differences. And if you compare the aqueous with vitreous, it is almost similar. Okay. So we have sclera, we have cornea, fine. Interesting stuff. So now you must have heard about the cataract. What is cataract? When the eye lens is, it becomes opaque actually over the time because of the hardening of the layer actually. So what the doctor do, they either remove the layer or they remove the entire lens and replace with some plastic lens. That is called the cataract surgery. And this is not difficult task because such a refractive index is easy to produce in lab, and you can just replace it. Okay. So the reason is extended eyeball. What is the other reason? The other reason is the power of the lens is too high. So if the power is high, if the converging power, when I say power, it's converging power. So how to make it less? By using some diverging power, isn't it? That's logical. Hello, hello.
Yes, sir.
Because power is high, so to make it low, what will do? You will add some negative power. Negative means some diverging power is required. Correct.
Yes.
So what we do is we in the path of the eye, we bring the diverging system. So what it will do is this diverging system will change this path slightly ahead. And now because it is divergence, it will eventually converge on the retina. So for human eye, because the human eye is receiving this dotted line. So for your human eye, the object is not at infinity. Where is object? Can you see this? For human eye, just a moment.
Yes, sir.
So I will believe that the rays are coming from here. I mean, eye is not aware that someone has bent before. So the incident ray on the eye will be appearing to be coming from this point. And therefore, this point is called the far point. What is this far point? This is not a healthy human. This is the far point of the person with defect. Because technically, this should be what? Infinite. So far point is the now the far point of the given person with a defect can only see if the object is either at FP or nearest to the FP. I mean less than FP. Anything beyond FP you cannot see clearly. So far point of person with defect. So how to use? I mean the question remains same. The distance of far point is measured from the optical center, which is O. So generally, when you wear a glasses without much intention, the glasses by design, because it is supported on the nose, by design the glass is not at O. So your glass and O will have some distance. We call it D. And when I say the far point is from optical center. So they you will be asked to find the power of the lens. What is the power of this lens used? So we can use the lens formula. What is the lens formula? 1 by V minus 1 by U equals to 1 by F. And 1 by F is equal to power. So we can say power of the lens used is how much? So tell me what is V for the lens? It is minus, can we write minus FP minus D? Can you see V equals to, this is the image, right?
Yeah.
So the object is coming from infinity and the lens is making the image there. So this is the FP minus D, and U is infinity, right? So power of lens, how much we're getting? Minus 1 by power point minus D. D is a small gap which you leave between the optical center and the glasses, because only for contact lens D becomes 0. Understood? So if FP and D are measured in meter, then this is in diopter. Assuming this is called diopter D. I hope you know the name. So when you measure things in diopter, you put a FP and D in meter. But if you want to write in centimeter FP and D, in meter, or you can write minus 100 upon, and AP and D are values only. These are not with negative. So this is D. Generally, we use this formula because we put things in centimeter. And you can clearly see the answer is negative. If you ask any person with myopia, he will say he is having negative power, minus 1.2, minus 0.25, which generally very, very small. Many one will say they have 0.25. So what we can add is for contact lens, the D is 0, and therefore the power will become 100 upon the far point. Understood? So if I ask you, if your far point is let's say 200 meter, what is a PL?
If sir, what?
If your far point, if person, technically the person should have infinity as far point, but what if your far point is 200 centimeter, which means you can only see something either at 200 or before 200.
Yeah,
You cannot see beyond far point.
yeah. We can't see clearly beyond that.
Yeah. So if your far point is 200 centimeter, what is your power of the lens required to see things clearly? It
1 by
is minus 0.5, right? Diopter,
minus
isn't it? Let's say if you can't see even beyond 1 meter, so you have minus 1D. Okay. Let's say if you can't see beyond 80 centimeter, so you will have 1.2 minus 1.2 D. So if someone will tell you, the next time someone will tell you the power, you can tell him or her the your far point. You cannot see beyond this on an average.
So you'll be assuming the small d to be 0.
Pardon? Yeah, yeah, yeah.
Oh,
A small d for contact lens, we take a small d as 0. But if it is not, if it is glasses, then by the construction we know that glass will be having some gap from the eye, right? Isn't it?
yeah, sir.
So that is called D. So this is how we solve. See, we have to use the formula. That's very simple formula. For myopia, if they no, if they do not mention the small d part, the gap, it means by default you have to go with the contact lens formula. So technically they should mention, but if you feel that okay, it is neither given nor it can be deduced from the context, then you can resort to the second formula, which is the contact lens formula. Is this clear? So in fact, in NEET examination for medical entrance, they do ask question a lot with the D actually, because if someone is going to become eye doctor, what you call ophthalmologist, then for such a doctor, this idea is important. So they should be good with all this knowledge. Although it doesn't matter nowadays, everything is done by machine. The doctor without knowledge of physics, which is the most case with most of the doctor, They are very bad with physics. They are good with bio and chemistry. And that is why we have bad doctors. Those who don't understand physics cannot be good doctor. Anyway, so for second part, which is hypermetropia, or you can also call hyperopia, or we call it near sightedness. Sorry, this is far sightedness. So what does it mean? You can see the any object which is very far away with ease, right? So if the object is really very far away, what will happen? For object at a far distance, how the light ray will come? Light ray will come parallel to the pencil
Yeah.
axis.
Parallel.
So your far point is still infinity, which means a person with a hypermetropia, the far point is infinity. The problem is the near point because it is coming from this and you can see clearly. So it means this will form the image at the retina. Now, the standard near point we know is D, right? So we check whether you can see the object at D clearly or not. And the answer is you can't see. So when the light ray will enter I from D, it will fail to converge because the light ray coming from the nearby object is diverging, so it's difficult to converge. So what are the possible cause? The reason is, you can clearly see the reason. The shorter eyeball, isn't it? If the eyeball size is shorter, then it will, before it will reach the, before it will get focused, the retina will pass. So that's a difficulty. Okay. The other reason is what? With old age, generally you are not able to bend. So these are two possible reasons. One is either your eyeball is short, which is like some sort of genetic issue, the lineage having the same. The other is the ciliary muscles are so weak that you're not able to bend sufficiently. So this is generally an old age problem, but as I said, it is possible for the younger one also if the defect is in the shape of eyeball. And these shapes, the defects are not much, it is just millimeter here and there, which is quite obvious, like it could happen for a variety of reasons, which we don't know. What is the remedy? You need to support some bending.
Then convex.
Yeah, because the power is, you are now, the your eye lens is not so powerful So to add some power, what you will do?
Add more converging.
Yeah, add more converging system, which is converging lens, which is convex lens. Understood? That's logical. So now your near point is no longer D, right? You cannot see a D. Your near point itself has gone at some distance behind. So your near point is somewhere here. Okay, I'll tell you where exactly by drawing the diagram. So if I use in path some convex lens, the O is here, this is the D. So what will happen is the light ray which will travel from here will bend a bit. It's difficult to show. Will bend a bit, and this will eventually get focused here. So if you extend this line, which lens has bent, it will intersect at here. And this is your, now let's say if this is, you are able to see now, which means this is was your near point. Okay, so your near point has shifted from D to NP. Is this clear? Kind of, huh?
Yes.
So what will be the focal length of this lens? What is the power of the lens? Power of lens. The power of lens is 1 by V minus 1 by U. So let's write down 1 by V. V is how much? Minus NP minus D, right? NP
Yeah.
and D all be measured from the optical center, O point. So, and U is how much? Minus D minus D, correct? So the power of lens we can write as 1 by D minus D minus 1 by, and you can leave like this, diopters. Okay. So for contact lens, what you can say? For contact lens, the D will be 0, which implies in centimeter. I have written very badly. So it is like a so it is roughly it is roughly 4 minus 100 by near point in centimeter, and near point is going to be more than 4. I mean 4, so this answer will be less than 4. So this is going to be positive diopters.
Sir, how did you get 4?
100 by 25. If I convert in centimeter,
The standard value we took.
yeah. So the D is standard, na 25. See, we
Yeah.
cannot change D. We can only change the NP. Person to person, NP will change. For example, what is the power? I mean, someone having the this hypermetropia. Who is having? Harshit. Who's having this hypermetropy? Like you have positive power,
Not sure.
and what is his power?
Plus 3 or
+3. So you can see clearly if I put +3, 4 minus 100 by the near point. So his near point is 100. Can you see that? So he can only see if the object is at least 100 and beyond without glasses. Understood?
yes.
So he can drive car on an empty highway, but it's not good to drive on a city. The city we have bumper to bumper traffic. Okay. Astigmatism means your plane of curvature, like the eyeball curvature is the issue. So you need to look slightly tilted, right? Your face and your the eyeball direction is slightly different.
Sir, I don't know. I just use glasses. So.
Okay, glasses. Yeah. So with all this, we end the defects of vision, and you can. So for what happens, like for astigmatism, the two mutually perpendicular directions are not equally visible. If you draw two perpendicular line on a paper, and if you try to look from the glass without glass, you can see one line is brighter than the other. Can you see that? Just check. Draw two lines, darker lines like this, and check which line is more brighter to you, or are they equal without glasses? Okay, let me draw it here and you tell me here. I'm drawing here only for you. Maybe this is the experiment.
Sir, can you repeat again?
So I have drawn two lines. Okay. So do you see the two lines equally bright, or one line is brighter than other?
Equally.
Right.
Equally bright.
Sir, I can't tell. There might be a difference, but it's not that much of.
So I think it's not that much for you also.
Yeah.
I mean, that is very minor astigmatism. Maybe you should consult a better doctor. He may suggest there is no issue. It could be. So you can just check this too. Some plane is, or you can choose other color also to experiment with. So just read as, I mean, this is not part of JEE syllabus, so you can just read SC or and solve it. So for defects of vision, you can solve all questions from SC Verma now. There are very few questions, but good questions are there. Solve it, and in case of doubt, you can always ask. Okay. Clear, guys? So now the last topic will be the optical instrument. So that I'll cover completely in the next lecture by taking 3 hour lecture. So next lecture will be the last lecture of your ray optics with defects of vision and optical instrument included. So we will finish comprehensively, and then possibly we will start wave optics and diffraction and polarization and other laws. So we'll try to finish the entire that part, and then what will be left is the modern physics, which I have taken. You can see the lecture, and what else. So in the other batch, you are already studying capacitor. So capacitor and current and magnetism and EMI. So that I'll cover in that batch. Okay.
Sir, you told that you won't cover the magnetism.
No, probably I'll cover it in a like fast pace.
Okay. So we should watch the lectures before.
Yeah, watch the lecture, and I'll try to cover more number of questions. So magnetism you can finish. See, if you have finished all of the previous topic, then you can also finished magnetism. Okay.
Sir,
But
but where
before
is it,
that, pardon?
where is it uploaded? Magnetism lectures.
Okay, okay. In my link, okay, where I have shared my link na, with you.
Yes.
In that link, only you can see. If you don't have, you just let me know. I'll search and I can send the link.
Okay.